this is Mr. T with another tutorial in our trigonometry sequence for Algebra 2. And today we're talking about reference angles. For notation we use theta prime, so we put a prime on an angle to represent the reference angle of angle theta. And we're going to be talking about how we find reference angles and one of the applications of reference angles in this tutorial. As it says here in the definition, we find the reference angle is measuring the angle between the terminal side of angle theta and the nearest x-axis. And our reference angles are always going to be acute angles. So let's look at the various quadrants and talk about reference angles. So let's draw an angle in quadrant 1. And let me fix our initial side here to get it in the right spot. So this is angle theta, and in quadrant 1 theta prime, the reference angle, and theta are going to be the same thing because our nearest x-angle, our x-axis is here, so theta prime is the same. So in Q1 we have theta equaling theta prime, or theta prime equals theta. So that was supposed to be Q1 here. So let's look at Q2. So let's erase this writing here, and let's move our angle over to Q2. So in Q2, again, our angle in standard form, this is our theta. We always measure it starting at the positive x-axis. And if we go from this angle to the nearest x-axis, that's right here, so this angle is theta prime. So if we wanted to determine in Q2 the value of theta, going all the way around to here is 180, and so if we subtract theta from 180, we get our angle. So in Q2, the reference angle is going to be 180 minus theta. And let's look at Q3, and we're also going to look at Q4. So let's clear our angle off here again and move into Q3. So let's move this around somewhere here. Let's make it down here. So now we have our theta in Q3. Again, our nearest x-axis, the temptation is going to be to measure this angle, but that angle is not next to a x-axis, it's the y-axis. So our theta prime is this angle. So it's either going to be 270 minus theta, or theta prime, I'm sorry, it's not going to be 270 minus theta. That would give us this angle. We want to figure out, we have to, subtract out this 180, so we have to subtract out this part. So in Q3, theta prime is, sorry for the brain malfunction there. I'm doing this on a Friday afternoon, so my brain is fried from this week. So again, theta prime is theta minus 180. And finally, if we look in Q4, if we move our angle around into Q4, again, this is our theta. And this is our reference angle, theta prime. So to get the value of theta prime, we're going to be taking 360 minus theta. Now, you could memorize all these formulas based on the quadrants, or it's pretty easy just when we're doing these to draw a quick sketch and figure out what you need to do. That's kind of the way I do it. I don't really bother with memorizing these formulas. So let's look at some examples using reference angles. So we want to find the exact value of 225. Now if we had a unit circle with all our coordinates on there, we could figure this out without reference angles. But here, by knowing the values of the angles in Q1, we can find the values in all of the other quadrants. So let's make a sketch of 225. So here we are on our initial side, and our terminal side, this is 90, 180, and we have to go 45 more. So our angle's going down this way. So again, this angle that I just made a sketch, and you don't even, to get this right, have to draw it even all that accurately. You want to get it in the right quadrant. So this is 225 degrees. This is our reference angle, theta prime. So we can see that we need to subtract 180, so our reference angle is 225 minus 180, or 45 degrees. Now the way reference angles work, the numerical value of our cosine, sine, tangent will be the value of the reference angle. But this is going to always be positive, so we have to do two parts. We get the value of the trig function of our reference angle, and then we have to figure out the positive or negative sign based on which quadrant we're in. So we know that the value of this is going to be cosine of 45 degrees value-wise, but we need to figure out should it be positive or negative. So let's think about in Q3, cosine is related to, on the circle, the x value, and in Q3 x is negative, so therefore cosine is negative. So we want negative the cosine of 45. And now we need to remember from our table of exact values, we talked about it on another tutorial, that the cosine of 45 degrees is square root of 2 over 2. And we need it to be negative because we are in the third quadrant. Alright, so let's look at another example here. So let's look at sine of negative 210 degrees. So we need to sketch negative 210. So negative 210, this is negative 180 and about 30 more. So let's bring a thing up here to approximately 210 degrees. Again, you don't have to get it exactly accurate. So this is negative 210 degrees. This would be negative 180, and we have to go 30 more, so our reference angle is 30 degrees. So we know that here the value of this is going to be the value of the sine of 30 degrees, and then now we've got to figure out, do I want a positive or negative sign here? So sine is, remember, related to the y-coordinate, and we're in Q2, and in Q2 the y is positive. That means sine is also positive, so we want the positive value here. And then from our memory, we know that the sine of 30 degrees is 1/2, so our answer for this one is positive 1/2. First problem. Now let's look at our final example here. We have our tangent of 480 degrees, so we would be going .360 plus 90 is 450 plus another 30, so it would be about here. So again, what we did was multiple rotations here, so 480 degrees. And when we were counting, remember this part here, we went 30 degrees beyond the y-axis. Now that's not our reference angle. Our reference angle is right here, which is going to be 60 degrees. So numerically, we want to find the tangent of 60 degrees. And now we need to figure out positive or negative. Remember, tangent is y divided by x. So in this quadrant we are negative x and positive y. So we have for tangent positive divided by negative, which is negative, so we need to make this negative. And then from our exact values, we know the tangent of 60 degrees is radical 3, square root of 3. So here in this tutorial, we've defined what a reference angle is and how to find them, and we've shown some examples of finding exact values of trig functions using reference angles. In another tutorial on solving trig equations, we will be using reference angles again. Thank you.